The goal of the Network for Earthquake Engineering Simulation Consortium is to accelerate progress in earthquake engineering research through the integration of people, ideas, and tools in a collaborative environment.
There's several different parts to NEES. There's the 15 experimental sites, and these are 15 earthquake engineering laboratories that are located all over the country that won an award to provide a substantial improvement to their ability to conduct research. Then there's NEES IT, which is the NEES Information Technology Infrastructure, which is, in a sense, the information technology glue that binds the sites together.
I think one of the most unique aspects of NEES is the fact that it brings together multiple institutions. Instead of it being one institution trying to attack an earthquake engineering problem by itself, you have a group of laboratories that are being brought together to try to solve major earthquake engineering problems that we haven't been able to solve before.
The goal of NEES is to accelerate the rate of progress in earthquake engineering. And we expect to accelerate the rate of progress by having much more collaboration and shared knowledge between these facilities.
We try to coordinate, pool resources and coordinate and make the best use of both dollars and information.
The financial advantage here is tremendous. The cost of doing the experiments within the NEES laboratory are not minimal. This is large-scale testing, so specimens are costly and it takes time to build specimens. By running experimental tests and generating data from those tests, in the simulation process, in the computer process afterwards, we can run additional simulations of that test with changing variables without the expense now of building additional large-scale specimens and the time involved.
It's, I think, changing the culture of how research is done, because now it's done more on a community basis and community sharing through community resources.
Up until this point in time, experimental research in the United States and in countries like Japan have always focused on the elements of a structure, like a column or a beam, but never the column and the beam, or in the case of a bridge, never two columns or in the superstructure of the bridge. So we focused our research to date on individual components. What is unique about this facility is that we can test an entire bridge system. So it's a bit like the leg bone and the thigh bone and the hip bone, rather than just looking at the leg bone alone. And so we are learning a lot about the way a bridge resists earthquake loads as a complete bridge system. I would say the only time a bridge of this size, of this scale, this complexity has been subject to earthquake loads in a controlled environment, anytime. First time in the world.
By using advanced facilities, collaborating through cyber infrastructure, and building a repository of research data, we are able to design and build structures that will better protect society and reduce damage due to future earthquake activity.
For more information about the Network for Earthquake Engineering Simulation, visit us at www.nees.org.